So good afternoon, good morning, good evening, wherever you may be in the world. My name is Steve Robinson, and I'm here to introduce a demonstration of SEER for manufacturing and how it can be used to estimate electrical harnesses. My colleague Keith Garland is going to go through that process and show you what the tool is capable of, both from an input and an output perspective. After the session, if there is any questions, please feel free to contact me, srobinson@galarath.com, and I will be more than happy to field those questions and answer any queries that you may have. So, without further ado, Keith, sir, it's over to you.
Okay, thank you, Steve. So today we're going to start an estimate for a harness assembly from scratch. So you'll see the entire process that you would be faced with, whether you were doing a should cost, a shop target, a bid, proposal, or one of the many ways that SEER is employed around the world for cost estimation. So we'll start a new project, and having clicked on the little button, we'll tell it the part number, the name, the assembly number, whatever we want to call this. So I'm going to call this Project X and put my initials in. We're going to work in euros. We can work in multiple currencies, or we can work in a single currency. So today we'll work in euros, in metric, 2017 base year. Click on OK. The tool will then split into the 4 main panes. So in the top left-hand side, here is where we'll build our work breakdown structure, the individual line items to transform our pieces of wire, our connectors, into finished harness assembly in this case, or dependent on the process employed, any of the other parts, components, whether it be composite, metallic, you could make using SEER manufacturing. So to insert a work element, I'll use this little push pin along the top, and we will select harness electrical assembly as our key process. As you can see, there are a wide range of processes available to you. So we can do machining, fabrication, mechanical assemblies, moldings, castings, forgings, composite operations, all of the aero that was built in conjunction with the F-35 Lightning aircraft and all of the suppliers in that group. Purchase parts, detailed composites, which we built with Airbus, and tube fab weld, which we did with Northrop Grumman. So here we go, electrical assemblies. The model uses knowledge bases. So I won't use one today so that we can see the entire process of manufacturing our harness. So I'll leave that one blank and click on, give it a name. Harness 1. Click on OK. It automatically demotes it as a child of the project, and we can now see what's behind the tabs that we have here. So the general tab is common across all of the processes. So we're going to tell the model we're going to make 100 harnesses in batches of 10, which is setup amortization. Then we can use a direct labor rate. So we can use the labor rate calculator if we wish. And I'll just quickly show you the capability we have in that arena, where we can tell the model the level of investment, type of operators, whether they're skilled, semi-skilled, number of shifts, and so on. All the information about the level of investment and the company data, which will then derive a labor rate for this given processes. We also have manufacturing shops here if we want to use some prepared ones. So we'll have an electronics medium shop perhaps we'll use today. Click on OK and accept that, and do the same for this one, and OK. So we got our rates for setup, direct and indirect. Now we start looking at some of the variables which you would set and lock down for your given organization. So how good are the people? How good are the team, their motivation, and so on. So let's say we have a team of people that are very highly skilled, and some good people. So we may have some apprentices, we may have some good people, we may have some superstars. So this uses a per mean average. So what happens here, into the algorithm, it will take 4 times the likely, 1 times the least, 1 times the most, divide that by 4, and the resultant factor will be carried forward into the equations, CERs into the background. Then we tell the model what type of environment we will be placing this cable. Are we going to put it on a high-end reliability aerospace military aircraft equipment, or could it be something for a vehicle down lower here, less onerous, less rigor, but still obviously have to work to a given standard. So today we'll make an aircraft, so we'll simply push our sliders to the top, fire them across, and click on OK. We have learning turned on. We can calibrate the model, and we can tell the model maybe we've made 100 prior units, so we don't have the expensive low-level production units or not. Today we'll leave that blank, so we're going to include the learning curve, and we can tell the model here that our 100 units will be operated quite hydraulic on a 85% learning curve. We can have the Wright, we can have the Crawford unit and cumulative average methodology for learning, and now basically we're set up and ready to go. So in the process specific, we can do cables, fiber optic cables, harnesses, wire preps, additional items to cover things that we don't cover. So it's maybe a special test or something that you have specific to a particular type of cable. So in cable, it's going from A to B, a simple sheathed cable like you would have on a household appliance, a kettle, a toaster will have a cable running into the equipment and back into the plug. Today we're looking at harnesses, so I'll say no to that one. I'll start with harness and I'll jump fiber optics, and I'll come back to that one later and say yes. And then we're faced with a choice of basic harness or detailed harness. Detailed harness has more inputs, it's more granular. Basic harness is just a cut down version of detailed harness where you have less information, maybe less time, and the estimate will be more indicative. So we'll say yes to detailed harness, and today we'll assume our harness has 3 branches. We know that, we're looking at the drawing in front of us, and the longest branch length is going to be 2 meters. Click on OK. We then add the harness list. So the model allows you to add your wires at your buying power into the harness, into the INI file, so that when we select the wire from here, we can add them, we can look at them, and we can look at the different wires. But what we were basically saying is you can also add or delete from this list what you use on a common daily basis. So let's use some basic 24 gauge, and we'll have, let's say we have 10 wires in total of this particular type. These are going all the way to 2 meters. We're not going to hot strip them. End type, we're going to crimp the end, and we're not going to wrap it. It's just going to be an open combed harness. Click on OK. So this is a growing list. So this is, we'll have a look at the other wires, and we'll put some, what should we put in? Don't want magnet wire. We'll have another, we'll have a copper wire here. And again, we'll have another 10 of these. And you get the idea. We want to crimp these as well. We're not going to wrap them, and click on OK. So this could be 20, 30, 40 types of wires in the list, which you can import from SAP into Excel if you have the willing. So we have 3 ends on our harness. So I'm going to select, we got just a normal torquing back shell. They'll be common. We'll have 3 of them, and we'll add that to our list. We'll have some connectors. So here we'll select the connector. That one. And again, we can add our own connectors to the list if we want. We've got 3. And we've got wires pinned. We've got 10 cables, 20 cables, 40 ends. So we're saying we're going to put 40 ends will need to be pinned into the variety of connectors. We're not going to have braiding. We can tell, if we did have braiding, we'd tell it the type, fabric, high temp, KMY fabric. And if we did that, we would then tell it the length that needed to be braided. We can do Vitron impregnation. We're going to assemble this on a pin jig board. Yes, we will. Are the pins obstructed? No, we have easy access, and the pins are 15 millimeters apart. Click on OK. Test type. So we will do Dipnico testing, which is a standard electrical test, and we are ready to present our harness as being complete. And that's what you need to do for creating a harness within SEER for manufacturing. If I just close that one, and now we'll look at fiber optic cable and click on yes, this is a new feature within SEER for manufacturing. It's recently been added in one of the latter releases. Here we can tell it what the jackets are. So we have a wide range of jackets. We can tell it the cable cost per meter, the fiber quantities, the cable length. I'll just enter 4 meters. And then the connectors, and we can see we have a wide range of available connectors here. We always have help, so we can look at the connectors, look at the connector types, click on more help, and we can see here the detail and the types that we're trying to estimate. So we have a better understanding of that sort of thing that's going forward into the estimate. So the help is written in HTML. You're able to edit that text. You could have your own spin on the text, local instructions, your own language, if that's what you need to do within the model. Material cost of the cable, optional, tooling cost, optional, so on and so forth. If I just close that one, open that one again, just to show you basic harness, which is a yes. Sorry, I need to close the other one before I opened it. And again, straightforward, how many branches, length of the branches, the number of wire strands, cost of the wire, a growing list of fittings as before, any coaxial connections, crimping, and that's all there is to it. So it's a lot less inputs, but still as effective if the information or time allowed is limited. That is SEER for manufacturing. Like I say, you can get information in and out of the model from an external source. So if I select one here, for example, select it, and I have one of them, click on OK. I can take that, I can copy it. I'm just going to show you how you would do it. That's a warning message. I haven't saved the file. So if I add a sheet and I paste that in, you can see the syntax. So the harness fittings are listed one at a time. The descriptions are what you could pull in from SAP. It's back shell number 1. So that's going to be common. So we're having all back shells. That's the different part numbers to 6. These are the cost and quantity. So I'll make these common as well. And then basically I just take that to the clipboard, copy that back into SEER, paste it in. So you can bring a lot of information in quickly, easily from other applications, particularly Microsoft Excel, which is made to make yourself life easier. Add your own fittings, add your own cables. They're all held within what we call a material ini file, which you have full access to. We encourage you wholeheartedly to add your own materials, fittings, in whatever way you see fit, because you know what you buy, you know your buying power, and so on. So here are estimates. We have detailed analysis. So we can take our reports. We can build our own reports. We have something called flexible export, which allows users to build their own reports. They can parse them out into Excel, into Word, where they can recreate their own standard reports that they're used to working with. So as you can see, a lot of information. Labour costs, setup costs, additional items, labour minutes, as well as detailed analysis of the operations as they took place. So that's SEER for manufacturing and the estimation of harnesses. Over to you, Steve.
Excellent. Thank you very much, Keith. As I said at the beginning, if anybody has any questions, please feel free to get in touch with us, and we will be more than happy to provide answers to those questions. Once again, thank you for your time. Thank you for Keith, and we will speak to you soon. Thank you very much.